Hey guys, hello. What's up? How are you? And I hope so you're doing super awesome and things are good for you. Welcome to the stream again. Back back again to the stream, and we're gonna try to finish, not finish, at least continue on the app which we were building yesterday. Yeah, at least that's the target, right? Today's video will be mostly about WebRTC and stuff like that. And yeah. Okay. So let's actually start. Hey, hello. Hey man, what's up? Hello. Welcome to the stream. We are gonna make an audio. So what we are building an audio calling application. This is the part 2 of the series, and we have done the authentication part right now. And in this particular video, we'll be continuing with WebRTC, and we'll be actually figuring out how we can transmit the audio data from one person to the next person, and that's the target. I hope so you are as excited as I am for this build, and let's see how far can we reach during this video. Okay, great. So let's actually fire up our project first. And if you remember, we were stuck on a bug we had. So we'll definitely try to solve that as well. Okay. Right. Okay. Here we were calling it audio calling application, and let's quickly show you what we have built so far. Yeah, WebRTC, it's really cool, man. WebRTC helps you to do a lot of very interesting stuff. Thank you. Let's continue. So first of all, first thing first, I'll just walk through what we have already built for all the people who have joined new, and then we'll be discussing what we are gonna do. What's the agenda for today's stream, right? So yeah, so we were using in the front end we were using React.js, right? And in the back end we were using as a Express.js as a technology. So in the front end, what we have built is we have this sign up and sign in form, right? So I'll just copy this, close this, right? Let's open it over here for now. So this was the sign up form, and and let's actually show you how does this work. So if I just sign up, oh, this is not the sign in form. Let's go to sign up, right? Sign up, right? Oh, there's no sign up. I want to go to sign up. It takes me back to sign in. So that was the bug we were facing. So I'll just walk you through. So this was the UI which we created. There's a dashboard stuff, and hold on. Okay. Then in the backend, I'll just walk you through the code. Okay. So this is the audio calling application which we were making yesterday, and we actually finished off with the authentication part. This is the server. We were using Prisma as an ORM, and if you don't know what Prisma is basically an ORM which helps you to communicate with your database. We actually build the initial stuff, all the stuff. We build the controllers and service only for the authentication service, right? And for the for the authentication service, we were again we use the JWT based authentication. And the JWT based authentication, we stored the user using its name, email ID, password. So this was all authentication which was done yesterday. We also made a hook through which we can determine whether the user has already logged in or not, so which is cool. So and there was a small bug in that hook which we're gonna fix in this particular video, right? So yeah, we are all set, we are all up and running. I'm excited for the stream. If you are also, hit that like button, and yeah. Okay, so now the first thing what I'll be doing is let's actually go to the use auth hook which we were creating, right? This had a redirect function, and this used to work like this. uh, yes, and we were actually fixing this thing, right? Hmm. So yes, but wait, hold on. If it is uh, okay, so let's take a secure as a parameter over here. Let's call it boolean. And if you give secure, right, and if the secure is true, right, then only like it will allow this to happen, and by default this thing will be true, right? So this is how you define the default variable. Uh, let's quickly go to the sign up, right? And let's go to the console and say secure true, no, false. We don't want the, okay. So now if I go to sign up, I should be able to go to sign up. Yeah, I am in the sign up form and it is working as expected, I think so. So let's actually sign up with a new account. We'll call it like, I'll just sign up with my account. So we'll call it J test account. So right now the target is to use WebRTC for this. Uh, yeah, if you have better suggestions, we can definitely explore that. So you can give me ideas. Things gaming. Yeah. So you can definitely give me ideas. We can go on that as well. So let's actually do root, whatever, root hash at the rate 123 is the password, and this is the account, right? So if I create the account created successfully, but it did not automatically, we were not able to go here. Yeah. So this is the dashboard. We'll be fixing that authentication bug in a while, but let's get started with audio recording, audio processing, WebRTC stuff, and then we'll see this. We'll fix this use auth bug in a while, right? So I just want to get like I just want to distract myself to something else for now, right? So if you don't already know, I would just want to take a moment and explain you what yes, the redirect function. So yeah, this use auth, I'll basically uploading the code. This function has some issue. So when I log in, this should have automatically like taken me to the dashboard. But it's not doing that way. So this has some bug. We'll be fixing this, but the authentication is working properly. Okay, so now what we want is there will be a list of users over here, which will basically be like all the users which we can connect to, and there will be here what will be there is we'll be having audio calling sort of like UI through which we can we can call anyone, right? So let's actually go to flat icons. So flat icons is a really cool website for downloading really cool icons, and let's call it call, and let's search for like some cool icons for call. So we have call, disconnect, right? So let's choose this one. This is a cool icon. Let's download this, right? Yeah. So this is downloaded by free pick. Of course, I'm giving the attribute. Okay. So here we have the phone icon, and we can, I think as we're using Vite, we can place it in the public directory. So in the public directory, let's create a new folder. And let's call it images. Inside that, we'll be transferring this images, right? This phone image. And what we'll do is we'll go to our dashboard and we'll start with other stuff. Now in the dashboard, we'll be using multi routing, like multi-level routing or nested routing or whatever you can say that. So we'll be going to our routes. No, we'll be going to our app folder where we have defined all the routes, right? What? No. Okay, this thing. Let's try this. Uh, oh, this also has a great icon. That's true, man. Can we find something cool? Yeah, this is great. This is great. If we are, yeah, this is a good option. let's go with what we have, and we'll also be using some of the icons from this uh, noun project, if I'm pronouncing it correct. Okay. So let's actually start with the WebRTC stuff right now. So first of all, what we'll do is we'll just create we'll be creating a page, and we'll be calling it, okay, let's create a folder. Let's call it dashboard. So everything inside the dashboard will be inside this. So let's move it there. And yeah, there you have the dashboard. Inside the dashboard, we'll have one more stuff, which will be caller page. This should be caller page. Yeah, this will be a caller page. Let's call it caller page, right? And let's create a new uh, React component, right? And then what we can do is, for now, like, let's say, as we are using Tailwind and Andy both, we can say dot text dot 3xl caller page. Now this caller page will receive an ID, so a user ID to which you want to connect, right? To which you want to call, or to which you want to connect, basically, simply. So this will be basically a dynamic route. Now, how the dynamic route works is basically inside this, which is dashboard, we'll just make it like this. So now this will be like this. No, the rendering issue is still not fixed, Akash. We'll be fixing it. For now, we are continuing it, right? For now, we are continuing to the WebRTC part. That issue is still there, and we'll be fixing it. So just after we are done with this, a little bit WebRTC. So we are just distracting ourselves from that part. We'll be fixing it for sure. Just give me some time, okay? After this WebRTC thing. Okay, so we have the route thing. This is now we'll be making a nested route. So inside the route, we'll be having another thing, another route, which will have a path, which will be dynamic path. So we can say slash user ID, right? And the other user ID, the next user's ID to which you want to connect. And the element which we want to have there is the caller page, which we have built, right? So we have the caller page, we have the nested route. Oh, what kind of like bad music, like horror music is playing? Man, could we have something else? Come on, next song. Yeah, this is good. This is good. Yeah, this is fun. Okay, so uh, this is too loud. I have to make this. This is good. Okay, so now what we have to do is we can just use this user ID to connect to the next person, basically, and to render what we want inside the dashboard. What we have to do is, in the content area, we have to mark outlet, because this is the, like, I'll just explain this how this works in a while. Just hold on. So basically, how it works is, basically, you have a parent, this parent, right? And whatever you are giving it as a children, right? Wherever you want to render that part, you just give an outlet element to that. Can't hear the music. Oh, you guys want to hear the music? Clearly. What's the case? Is it audible now? Okay. So the caller page is here. The user ID is here. Okay. It's not working. Should I make it louder, or? Okay, so now we have this user ID and this dash thing, right? There's an issue, man. This auth has a serious issue. I just want to get rid of this right now. So we have the user ID. Let's get rid of this dash. Can we make it work without this? Yeah, see. So the caller page is actually rendering inside the outlet, like where we have actually give the outlet in version 6, which is cool. So now we have the user ID over here. So dash is like that, and then you have a user ID, which basically, oh, there's no dash, man. uh, that's perfect. That's how it should be. Perfect. So here we can retry the user ID, but before that, let's do some WebRTC experiments, which is going to be cool, right? So let's actually try to build. For that, we need a little bit silence. Let's stop the music because we want to focus right now. Because for this part, we need some focus. Okay. So what we want to do is basically let's actually have a video player. Let's get started very simple, right? So let's have a video player and let's create a ref to this, right? So this is our player. Player ref. So we can say yeah, we can go over here and we can say player ref, right? And we can say use ref, right? Which will create a reference to this video object, and we can simply say ref is equal to player ref, right? Uh, okay. Once we have the player ref there, it is throwing an error because the type of player ref is incorrect. What we have to do is in the ref, we just have to specify the correct type. The correct type is HTML video element, right? I think the ref, what will be the type, man? Where are you working as of now? Like, oh, job wise? Yeah, I'm working at a company called Wi-Fi. It's a Mumbai-based startup. Yeah, so we have the type is not matching, so it should be mutable ref. Undefined is not a server type, legacy ref video element or undefined, or it should be undefined as well. Come on, what do you want? That's correct. Should I do like ref? That's still not happy with me. Create a ref to a video element react. Oh, HTML video element. I think I did this, but this is not working. See, HTML video element or null or null. Still the same error. It is not expecting. It says type mutable ref object HTML is not assignable to type legacy ref or undefined. Should I use this directly because that might solve our issue? It solved the issue, but what is legacy ref then? It's again complaining, man. HTML video element ref object. So what you have to do is it's react.ref object. So we can say ref object, and then we can say HTML video element or undefined. I don't want that. Initially it should be null. Oh, so that would work. Let's see. Right, if I just pass null. Okay, let's try that out. Oh, it worked. Awesome. Thank you. Great. So that worked. So we have finally the ref type defined, which is great. Now what we have to do is we in a use effect, what we'll do is use effect is basically a function. It runs whenever a dependencies change, which we pass in this array. But if you don't pass anything, it is like component did mount hook, so it will simply run the first time. So as soon as you're there, it will be running basically the first time. So you have the use effect, and then what you can do is we have something called navigator. Inside that we have something called media devices. Inside that we have something called get user media. Okay. So this basically helps you to kind of like get. Now this takes a configuration. This configuration is for me. TS is wizardry, and I've been to Hogwarts. I've not been to. No, man, it's completely okay. TypeScript is not a wizardry. It's very simple. Just be with me, right? This basically what over here. If you don't understand something, just write me out. So it's very simple. See, you just give a semicolon and you give like the type of that thing. So this caller function is like a functional component. So this is functional component. Similarly, if you have a function and you want to give the return type of that, like this useref is actually a function and you want to specify the return type of that, you give it like this, right? So that's how it works. These are called generics. That's the official term. So here you actually basically specify what do you want. So for now, let's it for fun, let's do like video and audio both, right? So we have the video as well as audio. We want to capture both of those stuff. And what we want to do is we want to say dot 10, which will give us a stream. Right? So this is like the type of this is basically a media stream, right? So now what you can do is this is very interesting. You can take that player ref and you can say dot current, sorry, dot current dot src object, and you can specify this into the stream, right? Okay, the left hand side may not be an optional okay, so let's do it like if this is present. So if uh player ref, so you're specifying generics for ref as HTML video player. Exactly, that means the return type or the return type of user ref will be an HTML video element, right? So that I can get all these auto completion which I'm getting actually right now. So player ref dot current, if there's a current defined, right? We want to say that the like this video should have that stream which we have got from this, right? So let's start simple like this. Uh, there will be few things we'll be doing. So we'll say autoplay true. You want to autoplay true, and we also want controls. I don't know why, but I just want to have the controls. And let's see what does this do, and let's actually fire this up. So as soon as you come over here, I don't know if it's visible or not, you can see it asks for the permission over here, permission of whether I want to allow this program to give use camera and microphone, right? So if I just allow this, uh, I just don't want things to echo very much. You can see I'm very much visible in the application, and this is actually capturing my video. So yeah, we can make this as like a video as well as audio calling application rather than only a audio calling application. But let's keep it for the next part, okay? So the video calling we can keep it for later on. Let's make it an audio thing for now, right? So if you don't already know what WebRTC is, I would just like to go to the official WebRTC WebRTC documentation, right? So if I go to guides, right, this is the WebRTC guide. WebRTC, by the way, this guy WebRTC is not owned by Google, but this documentation is maintained by Google, and it contains some really sick things, really awesome stuff. What else? HTML video player could cause linter to complain. See, linter. Okay, you want to know why this complained, right? This because this video could have a certain kind of ref, like so the player ref has to satisfy that the a video could be referenced as a HTML video element. So that's you're referencing it, so that type is required. That's why the linter was complaining before. Okay, so let's get started with WebRTC. So first of all, media devices, we already know, we have already done this stuff. We have passed the constraint at video true, and we have done all these things. Now what we want is okay, this is cool. Before I go further, I would like to explain how this is working, right? This is very, hey man, Imalino Perea. I'm sorry if I pronounced your name wrong, but I would like to just take a moment and explain how basically a WebRTC network works. And there is like a lot of different ways to design a WebRTC network. I would uh, I would be going with the most simplest one, which is actually uh, peer-to-peer networking, right? So like I don't know, I just hold up. Is it yeah? So how does this work? Is basically you have one client over here. So let's say this is your client, right? And you have another client over here, which is another client, right? So how does this work is basically this client has some kind of information like which identifies this client, and this client has other kind of information which identifies this particular client, right? And there's something called a turn server, right? Turn or stun server, right? So what happens generally is you just say okay, pass like my information to this client using this turn server. So you pass this to this and this to this, and then what happens is you have a network. Like now this client makes a direct connection to you, so this is a peer-to-peer networking. This client could directly talk to you right now, which is kind of cool. Now you can basically you have a peer-to-peer networking, and you could actually very simply directly have a communication. But this has a very major problem. This is not very scalable because every client is basically, so if you have a multiple clients, like you'll need to basically, imagine this getting all these stream from all these different clients, and it is not scalable. This is not a good idea to have like a peer-to-peer, which is also known as mesh architecture in WebRTC. But we'll be going with architecture right now, initially, right? In the second phase, we'll be changing it to something like MCU, right? MCU architecture. So yeah, that's the plan. Cool. Let's move ahead. So yeah. Hmm. Okay. So the first step is signaling. For signaling, we need to have a socket connection. So let's actually start with the socket connection. Let's actually develop the socket thing in the backend. So now we have the socket programming. Guys, are you excited for the socket thing? Yeah. So let's actually go to the backend first. So our server, wait, yeah, our server, and let's actually add socket.io. So I'll be definitely explaining what signaling is, how could we actually use it, a lot of those stuff. But I've added socket.io, and let's actually add the type definition as well. So we can say type slash socket.io. We have added both of those stuff. Now we have the VS Code over here, and let's actually go to the index file. Now this is the server index file, and we'll be setting up our sockets over here. So let's actually do it. For that, let's go and open socket.io docs. So yeah, socket.io docs, and I want the server installation, right? If you just go and search, I think there should be a search. Yeah, if you just search Express, this is how you do it, right? So first, what we need is we need the create server function from HTTP, the create server function. Right? Then what we need to do is we need to, yes, exactly. If you remember the whiteboard application, yeah, that was created using this particular thing only. Through RTC network, you can transmit anything, any sort of data, right? So it is not compulsory to have a video or audio data. It could be any data, which we'll be discussing in a while. So you have a create server, right? And then what else do we need? So after this app, I made a whiteboard too. Yes, also I made a whiteboard too. Yes, maybe you can put, if that is live, you can put a link to that as well. We can play with that as well. We can see, right? So we'll be having an HTTP server over here. We can say create server, and now we can pass our app inside this. So the app which we created, and now this last thing, it's okay, it's okay. You will eventually create something really cool. So yeah, just keep learning. That's important. Once you'll be like, just start making something, and you'll be feeling a need, right, to learn. And yeah. So the next is we have this HTTP, right? So we just replace this HTTP listen, right? And now what we can do is you can have your socket server like this. So what is session, man? You should express session, and then you have a server. And where do you use this server then? Okay, it's here. So you just pass your HTTP. Okay. So let's do all the server stuff inside another inside some like another place, because let's not make this place a lot more messier. So let's create a uh, new folder, and let's call it real time. So all these are basically real time socket based things, right? And you can create a socket.ts for this, right? And then let's now import socket, I mean server, from socket.io, right? So which is server, and we can create a function over here which will be export default a function which will be an anonymous function, right? Inside the function, what we need is we need an HTTP server, right? Which will be basically an HTTP server. I don't know what's the type of an HTTP server. What's the type, man? Uh, what's the type of an HTTP server? Uh, uh, it looks like this one. So let's copy this. And this is the type which we need, right? Yeah. Let's keep it server for now. I think, yeah. Not a server. I mean, let's keep it any for now. Like we'll be figuring out the type later on, right? So we can have like a shop like a global server socket instance. For now, let's keep it simple, right? So we can say const io is equal to a new server, right? And we'll be passing our HTTP server to this. And now, actually, there is few things to this. We actually have to set up our authentication. We actually have to set up our a lot of things to this socket server because we don't want to allow anyone to basically talk with our socket IO server. For that, what we need is basically if you just go to documentation, right? You can see how it works. We can go to the server and you can say socket instance. That's how you basically create the socket instance. Now, okay, cool. Socket instance. And I think it does have a middleware as well. I think, yes, that's what we need. So we need to set up an authentication. Oh, using TypeScript makes me appreciate Java. Oh, really? Oh, really? Java is on another level. Like that's a fully TypeScript solution. I had a lot of years working with Java. It was good, but I like TypeScript more. So use now you basically get a socket and a next function, and then like that's the socket has a body and that has the headers. So you can say socket dot handshake or like what is it? Use this is a middleware socket instance handling cause socket instance, and then you say on the connection you can do something, and then this is how it works. And the server instance, what you do is you just say okay. Initial level emitted just before writing the response header to the HTTP request and the session of handshake, allowing you to customize them. Uh, okay, okay. So let's write a normal middleware, which will do what is it will take it will give us the headers first of all. So the headers will be socket dot handshake dot headers, right? And now if there will be a token inside the header, so inside headers. So the token would be like let's say token is equal to headers dot dot authentication dot get, not user agent, man. We want the header which is like token. No, authentication. Authorization. Yes, authorization. And then if like this will have two parts, right? So the token will be in the second part. First is JWT. So if and let's split this. So if the token is present, right? So let's say const mm, 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 token split, right? You can say token dot split with space. If you remember, we were setting the token. So if I just go to the auth service, right? If you remember, while we were giving like setting up the JWT token, right? Hold on. We okay in the front end, right? So I think sign in or sign up, anything like that. Or we are directly setting the token. No, in the Axios, right? So you can see we just take JWT and then we pass it like this. So JWT, a space and then the token, right? So we just have to split it using space, and the first part will be the token, and So we can just say, we'll just make an object out of this, and we can say this is our token and this is our header, or like name, right? So which will be token dot split at 0, right? uh, yeah, what's wrong, man? It's correct. Oh, why? Yeah, maybe I should have stored it somewhere, but yeah, let's have it like this for now. And now what we can do is, if there is a token split dot token, let's verify this token, right? So for verifying, we'll be again using bcrypt. uh, yeah, we'll be using bcrypt. So import bcrypt from bcrypt, and then what we can do is no, why are you using bcrypt? We need jwt, which is JSON Web Token, right? So now what we need to do is, we need to like decode this basically. So this will throw an error if there is an issue. So we'll say what should we say? We'll throw that error simply, right? So we'll say try, and there will be a catch block where we'll be getting an error, and we can say next with the error if there is an error. Otherwise, we can say there's a middleware in Shocket. So if anybody is confused regarding this part, just comment down and just ask me, or like clarify. Let's clarify and let's see. So inside this, what we can do is, we can just say const decoded is equal to jwt dot verify or decode, and I think decode, right? And then you can basically pass the token, which is token split dot token, right? And I think, is this an asynchronous function or a synchronous function? This is indeed a synchronous function, and this gives you a string. I think so. It gives you a string. So decoded dot yeah, it gives you a string, right? So now what you need to do is, we have to change it into user data. So we can say JSON dot parse this decoded string, right? So after this, hold on. Okay, I think this is directly the payload. This doesn't come as a string. This is directly the payload, right? We can verify this. We can definitely verify this. So let's log the decoder and let's see how far we can go with this stuff. Now what we have to do is, we have to actually make a Socket instance and get like in the front end through which we can connect to our server. But let's actually initiate this in the index file. So in the index.ts file, right? So let's go and let's say import init socket from dot slash real time slash socket, right? And then we basically need the HTTP server. So we can say initialize socket, and we can pass the HTTP server from here, right? So socket stuff is here, right? So this will be looking for all the socket stuff, and here is our the middleware function which we're using. Now the next step, what we'll do is, we'll just let's actually do this, right? Let's don't waste time. So the email of the user will be whatever the decoded socket, whatever the decoded uh, JWT will be. Wait. As string. What happened, man? Why are you angry at me? Decoded is possibly okay. This could be possibly undefined, right? So we'll say if decoded is not there, or if it is present, right? If it's present, like let's go to else block as well. So if it is not present, throw an error. So say throw, or like say next new error uh, unauthenticated. So let's call it unauthenticated. And if this is decoded successfully, now we can say email ID is equal to the decoded JWT email. Right? Wait, why is it was giving me something? I mean, caret. These are all string, right? As string. Uh, no, I don't know. I'm not sure on this. This actually could be because this usually is like the directly the decoded object, but we'll be figuring out once we make the correction from the front end. Okay. So we have the email right now, and we can find the user information. Now how we can find the user information is, if you remember, we had built the database instance like data provider. So we'll say client is equal to data provider dot get database instance, right? And now you have the client, so you can just say client dot user dot find first, right? Where the email ID is basically the email ID which you provided from there. And now you can store it somewhere, so you can say const user details, right, is equal to something like that, and you can say await over here. You just give me some time and I'll be explaining you what is the use of this and how this is helpful. So just hold on till that time. So we can say async, and we have this, right? And the next stuff what we have is we have the user details over there, right? So now what we can do is in the socket dot I think it has a connected, it has a broadcast, it has a client, emit, handshake. Handshake has a body, has a header, it has a auth. So it has an auth, right? That's insane. Uh, socket dot it has, okay, I'm doing something wrong. I'm doing something wrong. I'm pretty sure. This is not how you actually this is not how you actually authenticate a socket request. Um, JWT auth in socket IO. Authentication using JWT. So what do you do? You just say socket and next, and you just verify it. So handshake.query, we are doing it quite correctly. So then you have the token there, and okay. So the verify function, oh, this okay. Now this thing would take a process.env dot jwt password as well, right? So this will take a password as well. And now what we can do is we can just we have the user details over here, which we'll be logging in sometimes. Let's see how we can actually huh, okay, okay. So here we okay, so we have finally the email ID, right? We have the so socket dot I don't remember. It is like client dot request dot client dot uh, request dot body socket dot body is equal to or user details. Can I put something like a data that basically data, that's what we want, right? Dot user details, right? So you can say user details is equal to user details, right? This will basically propagate every user detail after this, like every uh, to every socket which we'll have after this, right? Which is kind of cool. So next thing what we'll do is we can just call next without any error. So if this happens, wait, why the hell are we writing this over here? I mean, we should write all these inside the if condition, right? Yeah. So then what we can do is we can just say over here we can say next simply, which will take them to next. And yeah, of course this could be, again we have to be this, and we say invalid uh, socket. Hey, what happened? Let's check the JSON web token docs. So here we have JSON web token docs, and we want to actually see how does the decode function actually works, because right now I'm really confused about the decode function. So if we just say if we just see, hey guys, where, okay, so if we just see the decode function, uh, okay, so we have the verify. Okay, so we can use this verify, right? Verify works. We do not need the decode function. I mean, we can use the verify, and then we can, and this works, right? And this is not an asynchronous function. I mean, it's completely okay if we do it like this. Yeah, it's cool. So we have we have completed the socket authentication, which is really, really cool. I'm really excited for the socket authentication. And yeah, so let's actually now turn on the music, because I think we are done with the socket authentication, which is cool. Now what we have to do is we have to make a front end connection to the socket server right now. So let's actually work on that. So in the front end, we'll go to the we'll go to the main.tsx file, and we'll be wrapping our entire app inside socket provider. So we'll be having a context folder, right? And inside the context folder, we'll be having a socket context .ts xts. And now this will do what is, this will help us to provide socket in like throughout the application, everywhere in our application. So for that, what we'll do is we'll just we'll be creating a normal you sure you want to provide that invalid socket? Oh, let's see. What do you mean invalid socket? I did not got the thing. So what do you mean by invalid socket? I mean, yeah, this is incorrect. I just get it. But we'll have a check, okay? So we'll be writing a .env check in the beginning, like whenever our application starts. But till then, let's go ahead. Okay. So here we are making a socket context, and let's say like this. We'll say export default socket context, right? Now what we have to do is we have to actually create a socket context over here, so we can export that. So we'll say export default socket. Let's actually install socket.io on this first. So what we can do is we can just go to the and we can add socket.io client, I think. So the client side of socket.io, which is this one. So how do I so this is how you do it. So you just say socket.io client, right? So let's actually install the socket.io client, which is cool. So yeah, so we have installed socket.io client, and now we can use the socket.io client by importing it first. So let's create a state right now over here. So it's a socket instance. And let's call it set socket instance. And there's a use state, right? And then what we can do is we can just return. We can have a children object, so we can create an interface for this as well. Socket context. We could have a children, which will have like react.node, React node, and you can just say that, you know, this is a React FC, a functional component, and this is the context which we want. We call it props, and we can just pass this over here. And now what we can do is we can just have the children over here, right? And we can have something like we have to create a context, the const socket context is equal to create context, And then what we can do is, after like in the create context, we can pass basically uh, we can pass the Socket.io instance. And how do you create a Socket.io instance? Let's see. You just have an IO function inside that. Okay. Right. You have an IO function. So in the use effect, right? If for once, what you do is you just say socket instance. No, set socket instance is equal to new IO, right? And then you, yeah, I think now I have yeah. So let's call it provider. That's true. Is that correct? Right. And then we can pass null for now as a default value. And then what we can do is we can just use the socket context over here in the return function. Socket context, right? Basically this one. And then we can say dot provider. Wait, there's some kind of issue due to which we are not getting the auto completion and stuff like that. So oh, it's there's some kind of issue, right? There's something wrong. Yeah, now it's correct. So now we can say socket context dot provider, right? And now we can pass the value for the application. So you can say value is equal to the socket instance, right? And we actually have to find out what is the type of that. So we can say const instance is equal to new IO. Is it new? Do we require new? No, new is not required. So you can say IO and pass whatever the backend URL is, which is localhost port 8000. Right? And now what we can do is we can just take this instance and we can just set this socket instance, right? This instance. All right. And if you see the type of this is the type you get. Let's call it this of this type. Let's not actually have these. Yeah. Now we can do the same with this. We can say the type is basically socket, and we can leave this like empty. So this will be socket or undefined, right? Or let's call it null, and let's write null as a default type, right? Again, this will be as like a socket or a null, right? Which is a correct type. I don't know why it is angry at me. Oh, this is, oh, we have to give a default type to this as well. So let's give it like null as a default type. So now we have this. We will through this we'll be having we have to export this context. So through this we'll be having the access to our socket in throughout the application, right? So what we can do is we can just go to the main.tsx file and wrap our app inside this socket provider, socket context provider, and wrap our app inside this. And not what what we have to do is go inside this thing and just say children, so that everything comes inside this, right? That's cool. Now we can have Socket instance throughout the application everywhere, right? Which is cool. So now we have our application over here. Let's see, do we have any error? So far no errors, which is cool. Yeah. So okay. Okay, so now after this having this socket provider throughout the application, we can actually go to the main caller page, right? And we can have the socket instance over here. How we are going to have that? We're going to say let const socket instance is equal to use context, and then we can pass the context type or the context, which is socket context, right? Pass that and then you're good to go. You have the socket instance over there. Now the next thing is, let's actually get rid of this for now, right? Now comes the main part. Now here is like wait, why do I have a black bar? Okay, so now actually we'll not have this video tag as well right now. So now we have to actually set up the WebRTC. So let's look at the documentation right now. So let's see how far we can go. So the peer connection comes over here. Okay, so the peer connection, we can say there's a signaling server, and then you have the remote ID. So what the WebRTC says is, WebRTC specifically include the API for communicating over ICE servers. I think, wait, hold on. It must be communicating to my server right now. And then it says communication refused. Why was the communication refused? Why did my server refuse the socket connection? Okay, it crashed. Cannot find module util data provider. Okay, so in the socket, in the socket thing which we had, this URL is incorrect actually. So let's actually fix this first. So utils slash data provider. Yeah. Well, has that restarted my server? I think so. My server has restarted, which is kind of cool. And I could now actually send another request. It again refused. My connection is being refused, man. Why the hell is my connection being refused? Socket.io localhost connection refused. Is it the course issue? Is it the course issue? That's the question. I think we haven't set the connection thing. That's the reason. And let's set it up. So io.connection, io.on connection, right? You get the socket, and yeah. Why is it throwing an error? Connection refused, which is kind of insane. Why is it giving us the connection refused error? Oh, now let's figure out this. Why is it actually doing it? What is the thing we are doing wrong? So if we go to index.cs, we passed this, which is correct, and this is also working. And 5173 is the okay. Okay. So why is my connection request failing? So let's actually for now, like let's do something simple. So I will say i.connect on connect, log new connection found, right? So we found a new connection while this is there, and then what we can do is we can just see, do we what do we got in the back end. We do not get anything from that, but uh, try removing the auth logic and then check it. That's true. Let's try to remove the auth logic and let's see that that fixes the issue or not. Let's go like that. Hold on. Let's actually try to remove this auth logic and let's see. Is it? I think it's connection. Yeah. And then what happened? Client data provider. Client is declared. Comment this out. Comment these two out as well. Let's see now whether this works properly or not. We have the same error. We have the same error. Initialization the server instance, and then you just get the headers and stuff like that, and then you have the socket instance, and oh, it's connection, right? So if I just copy this and if I just paste this, that's exactly correct. And let's see, are we doing it correctly in the socket context provider? I mean, oh, it's 8080. Oh, the address is wrong. That's bad of me. Okay. So the address was wrong. That's the reason we were unable to connect. Okay. ERR failed. What do you mean ERR failed? Oh, this server ERR. Oh, this is CORS issue. So I think the CORS issue could be fixed by simply, going to this and in the socket instance, right? We can just fix the CORS issue by saying io dot. I think there's something called CORS. I think there was a documentation related to CORS, handling CORS. So what you do is in the, okay, so here in the, where you create the instance, you supply the CORS policies over here, and then you say origin, and this is the same what we do in the index. So this is the same CORS configuration we'll be using for the uh, for the sockets as well. So that's great. So we have that up in there. So we have the CORS configuration of the socket as well, which is great. So now let's see, does it work now or not? Again failing. What happened, man? What's wrong? Uh, what's wrong? Why are you not working? Just work. Okay. Oh, this is module cannot be found. Okay. Uh, Constants. Yeah. Let's actually try now. Finally. We did it. We did it. We did it. It worked, man. It worked. Finally, it worked. So we have the new connection found. Let's actually try to bring back everything which we have connected, and let's see, does it work as we expect this to work right now? And I think in the auth, we do need to provide the token and stuff like that, uh, which is kind of cool. So, so we do get a socket over here. So we can just log this. Like this will be a really cool. You can say log. I think new user connected. Socket ID is this. Now, what is the socket ID? Socket ID is basically socket dot ID. And there you go. So now I think now if you just go now, if you see over here, we should have a, like whenever we try to connect with this, we should have a new socket information. So let's see. Come on, man, just show something. It is not showing anything now. I don't know. It's sad with me or something. I think again this auth logic just did something wrong. Something is very fishy. This auth service literally did something really wrong. Let's actually go and comment out this for now. Okay. Will it work properly now? Okay. Was it all due to the auth service? I'm not sure of that. Okay. So now if we just refresh this, we get a, oh, we do get, see, new user found with socket ID, like all those 4 socket IDs, which helps us to create, which helped us to create the connection. So what I believe is, due to this authentication error, there was an error and it is not allowing the request to go forward. So let's actually now set up the authentication for the sockets, and then we'll be moving towards creating the stun server and creating the connection for WebRTC. Okay. So here in the socket context provider which we built, what we want to do is inside this we want to go and say auth. Right? Auth. What's the configuration? How do you how do you authenticate the client request? Hold on, I have to put my laptop at charge because it's really discharging right now. That's cool. Okay. So now what we can do is we can just go to the JSON web, Socket.io documentation in the client section. And do we have the authentication, like client authentication thing? Initialization, we have this initialization. Then, okay, that's something which I know. Can you tell me something about authentication? So you just say on connect, stuff like that, usage with bundler, offline behavior. Okay. Socket IO client auth, or not, it's auth. Authentication socket using JWT. That's exactly what we need. So we have this, which is okay. I mean, this is a bad idea. Who wants to do this? I want to use, like, I don't want to use this connect or anything. How are we going to do this? What is the auth object doing? Authentication socket IO client. Okay. Hmm. What does this auth object take? Does it take a token? I think it takes a token. So let's give it a token. So let's say process, import dot meta dot env dot wheat base URL. No, it no, it's local storage, right? So it's in the local storage. So you can say local storage uh, dot get item, and let's call it token. And we have this. What do you mean? What do you mean? What do you need? Like this or something? God. If I just give it a token, what will happen? Yeah, it's okay. So that works. So you can, in the authentication section, we can pass a token. Let's try to log this in the backend. Let's see what happens then. So if we just go to the socket over here, right? And if we just say io dot use not async something but socket and next, and if we just say if we just log this thing called socket.auth, socket.headers handshake.auth, right? Let's see what do we get. Auth, and then we can just simply say next. Let's see, will we actually receive this this thing or not? Okay, it's doing it. And then let's refresh this. Oh, we do get this. Oh, we do get the token. We do get the token inside the auth, which is amazing. So auth.token will be the token, right? We can use this. So we can now uncomment all these stuff which we had, and this as well. The only difference would be now we are not getting the token from this place. Rather than that, we are getting the token from this place, right? And the token is basically auth dot token. And there's no splitting or anything like that. We directly have the token and we're good to go. So we can say directly the token, right? Which is cool. Yeah. So now this should be able to connect and work properly, I think so. What do you mean web socket was closed before? Okay. Uh, hmm. What, that decoding was having some issue? What do you mean? Decoded. Let's actually log this thing as well. So if we just face this any error, we're gonna log that stuff, right? So yeah. Oh, that's the error we are facing. So it says JSON web token error, invalid signature. So signature is invalid. That's the issue. So we are getting the token, and then we say JWT this thing. So if just we go to the .env and oh, it's JWT secret, not JWT path. That's the problem which we had. So the .env, the env environment variable's name was incorrect. Okay. So yeah, and now it should be good, I think. It again gave me an error. What do you mean? Invalid signature. Uh, try to log this stuff over here. Right. It's correct, right? Yeah, the secret is being logged correctly. This is the secret, right? But still says invalid signature. Why? And how is the signature invalid? Either the token, let's try to log the token as well. So might be the token might be like not correct. Let's try to log the token as well. So if we just refresh this now, we do get the token as well. How can that be invalid, man? Come on, what do you mean? Uh, we get invalid signature uh, in the verify. We do get the token. We do give all of these things. But still we give. I think the issue is again we are using the same wrong in the sign up as well. That could be an issue. So in the sign up where the token is actually generated. So if we see over here, right? Where is the token generated? Uh, it's where is the token jwt.sign function? So handle sign up. We get check if you provide the right secret while signing the token. That's exactly what I was thinking, actually. Oh, this is the wrong thing. Okay, I need to go to auth service and then what? What do you mean, man? It's all wrong. What is JWT hash? And again, JWT hash. It's insane. All the secrets were incorrect. What we actually used. So again, we have to actually sign up again because all of them were incorrect. So let's go to our application. Let's go to the token. Let's delete it. Let's go to sign up, right? And let's sign up as j123 whatever at the rate gmail.com j.com 123, right? And j123 j123 uh, j123 funny error. Let's create the account. We have the account created. Let's go to the dashboard now. We are on the dashboard and the socket should not be an issue. So now, okay, it's all good. It's all good. It's all good. Yeah, the socket connection is working all fine. It's good. So the issue was we were using the wrong hash, which is a silly error. Which is a silly error. Okay. So socket ts, and let's actually remove this console log because we don't want that console log to be there right now. Now let's actually go to the JW, like actually go to the WebRTC area. So let's actually learn about the signaling thing, which is the first step of WebRTC. So here what we actually need is we create a signaling channel and we give remote client ID. Now this client ID is actually sent through a stun server. I think the WebRTC specifically include the API communication through ICE, which is Internet Connectivity Establishment Server, but signaling compound is not part of it. Signaling is need to be done. Okay, usually this is solved using regular HTTP based web API or RPC mechanism. The following code snippet is how you do it. Cool. So you need a signaling channel and you say you give the remote client ID. Might be the reason use auth not working properly. Yeah, what do you mean? Yes, wait, no. Use auth. No, use auth actually depends completely on whether you have the token or not, like in the local storage. So there the bug is something else. I'm like, that's what I think at least right now. So yeah, let's now focus only on WebRTC because this authentication and socket was a lot of hassle. We'll fix the authentication. Use auth is still a bug. We'll be fixing it. We'll see. So the signaling service here, but how to get this remote client ID and how to generate the client ID. Where the application will relay the necessary information before the peer connection is initiated. Initiating peer connections, and so what you do is you just do make call and you just get a icing server from like Google. Then you basically have a peer connection and you just pass the configuration, and the signaling channel you add an event called message, and you just say message.answer remote RTC session description message.answer await peer connection dot set remote description. You set it and then you have the offer. It's a little bit confusing, but let's dissect this one by one. And then you have a WebRTC peer connection, and then you do this. Okay. Okay. So set up an asynchronous channel that will. Okay. So you just say make call and you say you just pass the configuration. You just say WebRTC peer connection, and then you wait for a message to be returned back from them passing the configuration, right? And then if you have an answer, right, you have a remote description. You have a remote, like how the remote is, you have a remote description over here, and so you just set a remote description over here, and then you have an offer, which is set local description offer, and then you send the offer. So on the receiving side, we wait for an offer. Okay, so let's actually create this part right now, which is sending the stuff. So caller page. So we want to initiate a call. We want to call, like we want to make a call, right? That's exactly what we want to do over here. But we also want to understand that function before implementing it. So let's create a function, like let's call it let make call. Again, the same kind of function. This will be an async function for us, and we'll be basically having some things in common, like the. Okay, let's do it without. Let's do it the same way how it is doing right now. So we'll have our icing server. So let's call it config, and we'll be having the same ice server which this is using. Now, if you don't know the icing server is basically the server which initially, like in the beginning, makes the connection, right? That is the icing server, right? There you go. That's the icing configuration which we have. The next step what we need is we need an RTC peer connection. So let's create that. uh, const RTC peer connection, and you can say new RTC peer connection. Uh, a lot of you might be thinking, why do I don't copy the stuff and directly like use it? I think, copying the stuff, when you write it on your own, like line by line, you like just start making a sense, like things start making sense, right? One by one. So that's the reason. So next thing what we want is we just want to pass the configuration, and now you have the RTC peer connection, right? So let's call it peer connection. Like, why to call it, like, why to complicate the name, right? And then you have the peer connection, and then what this try to do is it basically it is listening for a message, and then it receives a message, but that, like, that guy, the other user, should send a message first. I think we'll be doing this in the next part, like not next part, I mean after this. So we have a message, and then you say if the message dot, there's an answer to that. uh we need a signaling server. What do you mean by signaling server, and where's that signaling server comes from? It comes from here. Now the question is, how do you get a remote client ID? Oh man, RTC data channel. Peer to connection is a part of WebRTC specified. Okay, let's see some sample codes. I think that then we can make sense of this thing. Go to the home. Let's go to this thing, and let's see some sample codes. We want stream RTC peer connection, basic single peer view source, right? And if we go to the JavaScript and main file, right, we have a start button. So what they do is, uh, hmm, so they pass the configuration, but then how do you make this stuff, which is, hold on. Man, where do you find this remote client ID then? That's the issue. Uh, hmm. I mean, can remote client ID be anything like a string of the next user's ID? What do you mean? Okay, let's try to give it like like a normal ID, a user ID, and then we'll think on like how can we improve that stuff. So let's create a signaling server. They call it signal server. I think that needs to be done by Shocket maybe. Yeah, I think the Shocket will basically initially transfer the Shocket client ID. And we are having the client ID in the params. So we can say params, we're going to use params. And then we can just say new signaling server. New signaling server. Right. It's throwing me an error. Cannot find signaling server. Oh, okay. Okay, this is Shocket. That's true. This is the Shocket. There's nothing called signaling server. It could be anything. Yeah, that's true. And then you have the message and like that. Okay. So what you do is you just say, so you receive a message after this, and that message has an answer. Okay, this is talking about our Shocket instance basically. So yes, you're correct. I think this is talking about our Shocket instance. So Shocket instance dot now I don't wanna do it this way. Peer connection dot add event listener message. Oh, so this is the signaling server. So it is not on peer connection. So first of all, we want to use a use effect, right? And we'll say that whenever if there is like if socket connection dot on, right? If there is a message event, right, we get a message. Now the type of this message is any, for now, consider it any, right? And now this any should have an answer object inside that. So the message dot any message dot answer object should be there, and if it is present, then we can create a remote description. We can create a remote description. Now this remote description will be a new RTC session description, and then you can say message dot answer, right? And then we can say await. So now you need the peer connection which you created for this thing, right? So eventually you will be having an RTC session description. So now we have to store this in a state. So we have to say remote description, set remote description, right? So it could be use state. We can say this could be of type RTC session description, right? Or it could be of like type undefined. And we can say set remote description over equal to the remote description we'll be receiving from here, and in the peer connection, when we'll be making the call, right, we'll be getting this peer connection. We can say peer connection dot set a remote description to the remote description which we had. And if we'll be not having this, right, so if there will be no remote description, we can just write a call, so remote description, and if it is present, then let's do it, else simply log an error and simply say no remote description found, right? Which is cool. Okay, so now we can use this to make call. For now, like just to make things simpler, let's use a normal let's use a spacer. No, let's use a button, and let's call it make call, make call, and then on let's set the type to be primary, and let's say on click, what I want is I want to make the call, so I can say make call. Cool. So this will go make a call, right? That so but so far we did not send something, right? Now we made a call, we set the local description, set. Okay, so we set the remote description. What is the local description then? Peer connection dot create offer await peer connection. Okay, so after doing this, which is an asynchronous function, so we'll have to make an await over here. What we have to do is we have to actually create so we have to keep the peer connection, because this should happen after we receive the message, right? So we made the call, and hold on, yeah, so this message thing should happen right over here. And now this should go right over here. We cannot store this in this state. I mean, we can, but we'll think about this later on, right? So like if we do this and just make this async, because this needs to be async, we can do this, and now we can just have an offer over here. So you can say const offer is equal to await peer connection dot create offer, which is cool. So we have the create offer now, and we can say await peer connection dot set local description. So is the offer. So offer is our local description and the message which we receive is the remote description. If you give both of the description to the peer connection, you will be basically able to like create a connection, right? So and the through the socket instance, we'll be sending now this thing. So we'll send this, we'll say offer, right? So you can say this offer, right? So we'll send this offer, which is the offer which we created, which is like on the top. And this offer is actually the message which we'll be receiving over here, right? So yeah, that's what it is. I think so. Uh, yeah. Once we do this, we'll be having a peer connection and we will be good to go. So that's pretty much it. I think in the backend, what we have to do is we have to just handle this offer, and we have to transmit it as a message to the uh, to the to the next person, to the person which to the person to whom this person is actually trying to call. Okay. So that's it. I think now we have to go to the socket connection in the backend, and we actually have to handle this thing. So after this all authentication thing is done, what we can do is we can say io.on. There will be an offer thing, right? On. I think it is not on or send, it's emit. So if you just go to the caller page, one thing we can fix is this is not send, this is emit, right? Yeah. Next thing is we in the socket thing, we have to do io.on offer. We do get an offer here. So now let me actually go here, right? So we get an offer, and now we have to transmit this offer to the person who the person is actually calling to. For now, just for now, okay. Let's do one thing. Uh, 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 uh. So how are we actually going to do this? We have to register this on every socket which we have. So io.sockets dot for each or dot on. Uh, so you get an event. What do you mean? How could we actually register this on all the sockets? I don't know. For now, I just have a very not very good idea, but I have this idea. So we can have like a const sockets, right, which will be an array, and we can exactly that's the target. I think the for each is not supported, right? So if I just go to for sockets, right, dot uh, there's like emit, we can so for now I just have a not very good solution, but yeah, this will work. So we can just have a like an array of this. So on the connection, what we can do is we can just uh, we can just say sockets dot push. Hold on. All connections, or like let's call it connections, and we can just push this to the connections. You can say connections dot push, or we can do it over here directly. So we can say socket dot on if this there is a offer thing there. We receive an offer, and we say to all other sockets, right? So we can say io.sockets.emit. Uh, this is hard, man. This is hard without creating an array, without creating that socket array. Uh, yeah. So say connections dot push. What do you mean, man? This is an array. This is an array of this. So connections dot push. You can add it on the connection event, so it be for every connection. Yeah, that's true. But how will you differentiate then, like between this and all other? Uh, like I'll explain you the issue right now. So just hold on. Right. So like if we just say socket dot on, if you receive an offer, uh, just send it to everyone else. Right. So you do get an uh, okay. You do get an offer over here. Then you can say connections dot for each connection. If the connection dot id is not equal to the current socket dot id, which is all other people, we can say connection dot emit. No, no. Yeah, connection dot emit. That's correct. Connection dot emit. We can emit the message right, with the offer. Yes, there's a broadcast for this. Correct. Broadcast is a better solution, right? Yeah. Let's actually learn broadcast. This is fun. Okay. So in the server, there's something called broadcast. And how could we do it? Uh, hmm. So then you have room, and then you can. Is it like is there a direct like can we say IO dot broadcast, or we have the adapter and stuff like that. We have the sockets dot something like that. Let's do it this way right now. Then we'll think on the broadcast. That's definitely better. Uh, there's a description over here. Let's actually try to read this a little bit. The server instance has few attributes. So first is you have the engine, which gives you the client counts, and then you can do this. May or may not be similar to count, and then initial header. Okay. Socket IO broadcast. Right, let's see the broadcasting events. Yeah, that's true. So to all the clients, from server to the all the clients. Now, how do you do that? Is you say on the connection socket.broadcast.emit. Okay. So, oh, this is how you do it, right? That's cool. So we can just instead of going to the every connection, we can directly say socket.broadcast, and then you can have like an dot emit function, and you can emit message, and then you can pass the value, so which is offer. That's how you. Oh, yeah, this is correct, right? This is how you do it, right? Yeah. So yeah, that's exactly does what we intended to do. It does not send it to itself, it sends to everyone else. And yeah, that's good. Okay, so now let's actually try to run this and see does it actually work or not, or are we actually able to make the connection or not. But let's actually go to the WebRTC documentation and let's see, do we have anything else to do. So through the through the signaling server, we did receive a message. So after receiving a message, what should we do? That's the question. In the caller page, in the use effect, let's do like in the socket instance dot on, we receive a message, right? So it's already done. Right? When we receive a message, we just do this. Uh, on the receiving side, we wait for the incoming message before the. What do you mean? I mean, we have the receiving side, and this like is the same right now. So if you just see it, it basically checks for the message event, and if there's a message dot answer, then it does this. Oh, this is a message dot answer and message dot offer. Okay, that's the difference, right? So we can say if we just receive a message, right, which has, let's say, message which has like the message, right, which could have like an offer and answer. So you just if you have a message dot offer, right? So if you have an offer, what we can do is we can just say peer connection. So now you actually need the peer connection thing. Okay, do we have to do everything like at one place? Come on. So message, and then what we can do is we can just say the peer connection dot set remote description, right? And then it creates something called RTC session description, which we already did before. RTC session description. No session reports. We need an RTC session description, right? And inside the RTC session description, we need the message dot wait. This is offer, right? This answer. We are having the answer, and then we have the offer. And then we simply say message dot offer. And then after this, I think we'll have an answer and send an answer. Okay, there is two kinds of event. One is the answer, one is the okay, there's two of these. Got it. So you can say peer connection dot so the your answer would be const answer is equal to we'll definitely be transferring this to like a call like this, so that you when you call you actually receive a call by playing some sound or something like that, like when you actually receive a call. But let's first learn this, and then we can go on experimenting on stuff. So in the answer we can say await peer connection dot create answer, right? And then you have the answer. Okay, this should be asynchronous now, right? And then we say await peer connection dot set local description, and then you can say answer. And then finally, through the socket connection socket instance, you just emit an event and you call it answer, and just you transfer the answer. Now here what we have to do is we have to go to our socket instance over here, and we have the offer and we'll have the answer as well. So socket dot on right. So we'll have an answer as well. So here in the answer, we'll be having the answer, right? And again, we have to do the same. Socket dot broadcast dot emit message, right? And in the message, we'll be having the answer. We'll be doing quite the same thing. And I think that's pretty much it. We should be able to do it now. Yeah, it's working. There's no error so far. So let's try to like test this. Let's try to make a call and let's see what happens. We do not see an error so far, so that means that should be working. Just to test whether things are working or not, let's actually send a message. Okay, we do not have a receiving end, so there will be like we need a two instance of this, right? So let's actually pop this out. Let's refresh this, and let's refresh this as well. If I just make a call, if I make a call over here, what happens? We have to like, of course, there's like we are not logging or doing anything. That makes sense, but So if we do receive a message, right? So let's actually unpack this and let's actually see how does it work. So we have an offer here and we have a message wait. So let's log this. Say so offer received, right? Uh, offer, let's call it offer, right? And in the message where we actually have the answer, let's call it answer. But why are we giving, like, why are we doing it two instances of this? Does not make sense, right? So we can just do the same thing over here, right? So because both of them, like, why we are registering two events for this, which does not make sense, right? So we can just do the same thing over here. Okay, so and we can transfer this entire thing in the use effect, which will be a better place to keep this, right? So because we want to register all the events over here, right? Don't worry, we'll be definitely having peer connection. We'll be giving you the peer connection. Just just stay calm. Peer connection, right? And we'll be having again a peer connection, set peer connection, right? And then we actually have to give the type of peer connection. So uh, RTC peer connection. So this will be of type RTC peer connection, right? And then after doing all these things, right? Uh, uh, right. Let's set the peer connection over here. I mean, yeah, set peer connection to the peer connection which we have. Yeah. And what we want to do is we want that if there is a peer connection, then only do this, and we'll make it on every peer connection, right? And whenever this unmounts, right, we want to like detach the message event. So we can just talk about dot close, or what do we call it? Close, I think that's what we call it. So close uh, message. What happened? We are doing something wrong. We are doing something wrong over here. So there should be no comma first over here, and there should be a return over here, right? So not close like that. We want like disconnect or socket dot on uh, close connect. Is it disconnect? Uh, huh. It's socket dot off. Okay, socket dot off. So yeah, off, and let's call it message. So this will basically turn off the message, right? So if we receive a message and it does contain an answer, we'll be setting. So this is an answer. This is a remote description, right? So we set a remote description, and if this is an offer, we set it as a local description. We set it as a wait. Why is it remote description in both of them? That's weird. Hmm. Set a remote description. Oh, see, that's wrong, right? So we are setting a remote description over here, and we say that's the remote description we received. Here, right? So in the answer, we are setting it as a remote description, which is correct. And if there's an offer, right? So if there is an offer, uh, that is also a remote description. Huh. Both of them are remote description. We'll be thinking on this a little bit, uh, like in a while. Yeah. So let's actually see does it actually work or not. So we'll say, right, so this is the socket IO socket IO message event, and we just say log message, or like let's say message, right? uh, and let's actually have the message thing over here, right? And let's see what do we see over here. I mean, it will be fun to watch. So we get this over here. Let's copy this. Let's paste this over here. And let's make a call. Nothing happens. Nothing happens. Nothing happens. Let's go ahead. I think we might have something else. So we have the ICE candidate. Oh, this is the ICE candidate. Okay. So we need a ICE candidate. Listen to the local ICE candidates on local RTC. So this will also be in the use effect, I think, because yeah. So you can say peer connection dot again, if let's keep it inside this. So there should be a peer connection for this, right? So if I mean, we can just keep this peer configuration and all these stuff as well on the use effect. So then we will not require this thing anymore, or this thing, right? So there will be no if condition. At the end, right? At the end, we'll be setting the peer connection to be like what we have, right? This is completely okay. And now what we can do is we can just eliminate these stuff. Uh, so if there is a peer connection, then do this, right? Otherwise, if there is no peer connection, simply log. We do not need this anymore. So simply say notification dot error. Message will be no peer connection found, right? So now once we have this peer connection, we can do this. We can listen for the ICE candidates. Let's do that. So in the peer connection, we can say add event listener, and we can say ICE candidate, and we do receive an event for this. Right. And we do receive an event for this, and then what we can do is we can just say that event should have a candidate, right? And if it does have a candidate, we can say signaling server we can show socket instance dot send or dot emit uh, uh, new ICE candidate. So this is like the type of event it wants me to emit, and we say new ICE candidate, right? And then the event which it sends is like event dot candidate, which is cool. And then you say if you receive such thing, like if you just in the socket server, if you just on, right? So you can say on, right? On message. Again message, are you kidding me? Insane. It we could have used like a different sort of events for all of them. What, there are variables with duplicate name peer connections. Wait, I cannot find a duplicate one. Let's see, we'll find out. Okay, so here we will be receiving a message. Okay, so again, this is not required again, so we can just transfer this again to the same place. So we have the message and dot offer, and then if we'll have message dot ICE candidate. We are doing a very big mistake right now, which is like we are not sending it as like a message dot like offer answer and ICE candidate, which we will be doing. eventually. So if you just say, if it has an ICE candidate, then we can try and we can say await peer connection dot add ICE candidate, and we can say a message dot ICE candidate, which will be C candidate, and then we can say catch E notification error message, there was some issue during adding ICE candidate. Okay. So far we have done this, and now next what do we need is basically we require everyone, like wherever we are emitting, this should be like this. This should be like this, right? Because now why this is like this, because then only we can say message dot answer, right? So this should be like this. Same whenever we are having emit, let's say where, so we are emitting answer, we are emitting new ICE candidate, uh, that should be also like uh, it's getting very confusing. Will will be actually I'll discuss this. Just let me do this, okay? So then after I'll be discussing this. So let's say ICE candidate. Okay. So it is a little bit confusing, I get it. So then you have the ICE candidate, and then it's, see, this is correct, right? And then wherever we are making an offer, that should be like an offer, right? So offer is done, the ICE candidate is also done, and so the answer is also done. I think in the wherever we are emitting the answer, where it is, where it is. Okay, so let me explain this. Okay, now I'll be explaining this. Hold on. Oh, here it is. Let's see. So yeah, let's actually try this. Does it work or not? So if this works, uh, that's good. If it doesn't work, that's also good, because then we'll have to fix it, right? So maximum depth. What do you mean? We have an infinite loop. Okay, let's explain this right now. Okay, so let's explanation part. How does this work is basically, so as far as whatever I have coded, my understanding is basically there is three parts to this. First part is the offer which you make. So you just call someone just like, hey man, I want to connect to you, right? And then you basically answer to that offer. You say, okay, I want to connect to you. And then finally you just match and stun server. So stun server is the middle server which kind of like relay your information, right? So you just have to match all these three things in order to connect with one person to another person, right? Simple, makes sense, right? So far very clear. Now this all starts with like when you click the make call function, right? So when you click the make call function, what happens is you just now actually we do not need this thing. Wait, okay. So let's actually again. So when you just say make call, right? What happens is uh, you just create an offer. You just say, okay, man, I want to connect with this particular person, and here's my offer. And you just emit your offer using your sockets, right? You emitted your offer. After you emit your offer, what happens is it basically, if you go to the backend, what we do, simply we take the offer and broadcast it as a message which has offer in it. Now remember, offer is actually an object, right? So if you just see the caller page where we have sent the offer, which is like over here, offer is actually an object, right? So here in the message where we are receiving the message, we say if it is of type offer, right? Like someone else is giving us the offer, right? We set it as a remote description, so that like that is like that's the remote people who we want to connect to, right? That's the remote description, right? Then basically after this we also have like a offer. So offer is already done, right? So I've explained you the offer. You basically, and after you have an offer, you create an answer. So you have an offer and you create an answer. You send an answer, right? and that answer is received over here in a similar fashion, right? So you have this in the shock. So if you see that we have the answer, and the answer is also emitted likewise, right? So we receive that answer over here now, and like the answer which you receive is basically uh, like then use, that is like the wait. So right, so that answer is your local description. So answer, like what you are giving, is your the local description, if that makes sense, right? And if you're receiving an answer, that's a remote description. This is confusing, I get it. I'll be explaining it again, but let's make it work first. Okay, so first of all, what we have to do is we are emitting this ICE network. We have to do the same stuff again. Socket dot on, right? uh, I am becoming really bad at describing stuff for some reason. ICE info, like icing server, or what was it? Icing server. Right. Now next thing what we need to do is same stuff, right? So we just have to copy this, uh, emit the icing server now, and just copy. Oh wait, no, Control Z. Copy and paste this over here, right? So now we actually will be able to. Okay, wait, hold on. What do you mean, man? What do you mean the connection is it? Why is it doing this like this? Okay, this is correct. Okay, so now this is okay. Now if we just make a call from this place, right? If we just make a call, right, I should receive a console log over here with the answer, which is not happening. So cool. uh, it's not happening for some reason. Let's debug this. Let's see what is the issue. So let's start with like the use call, do the make call thing which we had. So the make call basically had the peer connection, is like if the peer connection is there. So let's actually see, are we receiving this in the on our server or not. So the offer which we are sending it from here, which is this thing, are we even getting this or not? So log offer, right. Cannot create so many peer connection. What do you mean cannot create so many peer connection? Are we cannot create so many peer connection? I mean, are we creating it again and again and again and again? uh oh, we have that's funny. That's funny. uh oh, not here, I mean, uh why it's saying cannot create so many peer connection? I mean, what do you mean? There's an internal server error. So where is the error? What do you mean? Okay, there's an error now here. Your PC is dying because of the renders. Okay, let's close this, and let's try this again. Let's try this again. We have this. Uh, it's again and again. Like, why is the RTC peer connection created like twice? Because when we just have it like, oh, why is this? Okay. Ah, that was the issue. See, we were having the peer connection over here, and yeah, that would, I think that would fix the issue. Now we'll not have like multiple thing created. Localhost 5173, right? This is fine now. There's no multiple peer connections, right? So if we just now try to do it again, we should have call, wait, slash test slash test, right? And if you just make a call, wait, why you, I'm trying to make a call, man, come on, what do you mean? Do I get a console log in the backend? We do get an offer. See, we made it to twice, right? So we do have an offer. And okay, I think the connection was successful. I mean, we are sending the message, right? So if we just go to the socket, we are sending the message with the offer, with the answer, and with the ICE server, right? So in the caller, if we just see here, we have the answer, we have the offer, and we are logging in the message, but we are not receiving it here. Why we are not receiving it here? That's the question. That's weird. Why are we not receiving it here? Huh. Why are we not receiving the, okay, see, we are having it here. I mean, we are having the offer over here. Type is offer, right? uh, but we are not receiving it in the front end. We are logging it over here, right? So if we just say, how should we even debug this? uh, is the spelling like different of the message? Like, did I message, I think this is the same, right? This should be triggered, right? This should be triggered, right? So whenever I make a call, that should be triggered, right? Ah, it worked. It worked. It worked. It worked. It worked. Awesome. It worked. Uh, so yeah, it worked. And then we have to do like this message thing. And see, we have the offer over here, which is cool. So we have an answer and we have an offer, and it's working. We have made an RTC connection. Yes, now we can transmit the audio through the RTC connection. So RTC connection has been made. Again, if you, Yash, was this clear? Yash, was this clear? Like, do you want me to explain how this works now? I think this is clear, right? So you have the answer, you have the offer, and you have the ICE candidate. And if there's a confusion in the ICE candidate, I can go on that. What do you say? What do you say? We have made the RTC peer connection, which like quite successfully. I'm very happy. Let's remove all the console logs. Okay. So we have removed the console logs from here. Let's remove this one as well. Now, yeah, dab, which is cool. So now what we have to do is we have to actually send the data from one computer to the other computer. So let's try to do it. For that, let's again dig into the documentation and let's see how we can do it. So, oh, so this is the connection established thing, right? So explain the ICE candidate. Okay. So if you remember, we had a whiteboard over here, right? So this turn server or this white, okay, let me do it like somewhere else, right? So you have your client one over here. So you have your client one over here, right? And you have your client two over here. Right? So basically you have something called an ICE server, right? So initial information about like how you should connect is transferred through this icing server, right? So what happens is you create an icing server, you give it your configuration, and you send that configuration through the socket to the, like, I mean, send the configuration, like let's say this is your socket server, right? You send it to the socket server sends to this, and now they both have the same icing configuration, and now you both can connect. Basically, this is one more thing which should be same or in sync before connecting. That's how icing server works, basically, right? If that was still confusing, we can cover it more. Like we can, both of us can do a more R&D on this, maybe, and we can get. So let's do this as well. So let's actually make const connected, set connected, and then you can say use state, and we can say false, right? And then we, on the peer connection only, we can say peer connection dot add event listener and connected, right? Connection state changed, That's how you do it, right? So then you get an event, right? And you say if event dot connect, what is that? Connection state. If dot event dot what do you mean, man? Okay, so if event this is peer connection. So if in the peer connection dot connection state is connected, uh, is equal to connected, then set connected to connected, right? Okay, and no, connected, sorry, true, right? So now, and we can show it even in the UI right now. So we can say dot text, sorry, if it is connected, right? We can say div and class text 3xl, and we can say connected. Uh, text green 500. We can give it question mark over here, and in the or side we can just do the same thing. Why are you doing it like this? Oh, let's do it like this only. So let's have it like this, and let's call it disconnected, right? And then what we can do is we can just give it as a red color. Yeah. So let's see how does it look. So we are disconnected right now, and if we just have one more tab open, and if we just try to connect, we both should be connected, right, after making a call. uh, what went wrong? Uncaught exception, RTC peer connection, failed to set remote server, SDP, called in wrong state table. Oh, we have to refresh this. Same, we have to refresh this as well. I think the previous state was preserved, and that's the reason we were getting that error. Why aren't we getting connected, man? What's the wrong? Uh, Phew, there's some kind of issue. Why is this connected not working? And what do you mean? Connected, right? Is this even getting called? Log event. Is this event, is there any message as well? Let's say log message, right? Uh, refresh this, refresh this. And if you just do a make a call, hey, we stopped getting, what happened? The backend crashed. What's wrong? It was working all fine before. What mistake did we do? What do you mean? What's wrong now? Hmm. It suddenly stopped working for some reason. It stopped working for some reason. Let's actually restart our backend server. Uh, then why isn't it not, why does this stop working? Let's try to remove this listener. I think that might have got some issue. I mean, that's all what I've added, man. What's the issue? Why is this did it stop working? I don't know what went wrong. Let's just control Z. Okay. Till this state, everything was working, and I can confirm you that. What happened? Why it suddenly stopped working? Why? Did I do something wrong over here? I think that's all right. We were having offers. Hmm. Oh, connection refused. That's weird. That was working completely okay, right? It's all fine, right? If I just make a call, it's not working now. Insane. Or do we have the offer? We did receive the offer, of course. We do have an offer. Uh, and in the front end, the socket server is not working. That's weird. It's not even the WebRTC issue. WebRTC is working completely fine. The socket server is simply saying, I would not transmit your message. I don't care. Something like that. So we have it over here. We are broadcasting it. We are emitting the message over here, but we are not receiving it in the front end. What the hell? What is happening? This should be triggered, and we have a message over here. Is it socket connection issue? What do you mean? Uh, oh, now this is working. Now this is working. Okay. This worked now. This is weird. And yeah, that could be an issue, right? Yeah. Yeah, I just provided this dependency, and I'll even say like, okay, if you're going this, just have a check whether you have the socket event or not. Right. Okay. If there is a socket instance, we just do this. Right. And again, this is okay. Oh, that's the issue. Yes, that was the issue. Exactly. That's the issue, you know. It was not having the socket, our socket server was not ready before we were using it. Yeah, that's exactly the issue. So we can say const again. Now we can just go to the connected thing. Set connected, use state, and connected false, right? And then we can now have this all these things. Peer peer connection dot on no peer connection dot on connection state change. We get an event which we do not use, so we just say if peer connection dot get an event. What do you mean? This is correct, right? You cannot spoke on possibly null. What do you mean? This is the peer connection. How can this be null? It's weird. I think it is add event, something like that. Add event connection state chain, and then you basically then you can pass a callback function to this, and then you can say set uh, set connected is peer connection dot connection state is equal to connected. Yeah, and then we can do that stuff over here. So div if connected, then connected, right? Otherwise Not connected. You have state with the same name. Where do I have state with the same name? I think um, it's all fine, right? So this is the peer connection which I actually wanted to make, and this is the connection. This is okay, I think so, right? And then we can just give a style to this. We can say font size, maybe like 14 or 19 pt, right? And then we can just say the color to be, if it is connected, right, it will be green. No, actually, what is the question mark? Actually, this is not like this is actually a yes, true. That's true. Yeah, that's true. That's true. That's true. But it doesn't impact, but still, that's an issue. Okay. So we just back like this. It's any type. That's fine, right? But you reinitialized it. That's true. So now it is fine, right? So that's a backtick. So that's a local instance, and then we simply say this like this. Yeah, looks right to me. Let's refresh this. Let's refresh this. Let's make a call. RTC connection failed to set a remote answer. Called in wrong state stable. What do you mean? Failed to set remote answer. Failed to set remote answer. Called in wrong state stable. There's a bug. Let's try to resolve this. No. Why we are getting this error? Failed to set remote answer SDP called in wrong state stable. What kind of bug is this? Uh, let's actually try to find out. Set remote description. The main problem is when it is actually trying to set the answer. So set remote description, set the local description, and then you create the answer. So what it is saying is, it's saying set remote description on RTC peer connection, failed to set remote answer, STP, called in wrong state stable. So either we have this wrong spelling, or there's a issue with like how we are dealing with stuff. Let's actually verify this. So if we just say answer or like message, is the spelling and everything is correct? Let's see. We receive an offer, right? We do receive an offer now. So if we receive an offer, that means the bug is over here. So So we set a remote description and we say message.offer, which is OFFER, which is correct. Right? And then uh, what is Z? I mean, why this is this is funny. Why do we have the Z over there? Uh, what happens with the offer? Local peer dot create answer. Right? Yeah. RTC peer connection filters and unstable. Hmm. We are doing it something wrong over here. Uh, I failed to set. Okay, so we have the offer and answer. We have an offer which we start with, we send it away, and we receive an answer. Uh, inside the answer, are we doing this correctly? What is throwing the error? It was create answer. Yeah, that's correct. It was create answer, and I have written that, but now there is some kind of bug. Set remote description RTC peer connection failed to set remote answer. Called in wrong state stable. What do you mean by this? Yeah, RTC. The reason why I'm getting this error is because when a third party joins, it sends an offer to two previously connected users and therefore it receives two messages. Since one RTC peer can only establish one peer-to-peer connection, it will complain when it tries to set remote description on the answer that received because it already have unstable connection. Okay, the problem is it's actually getting triggered twice or more than one time for some reason. Okay. We have to see the backend now because I think we are getting connected more than one times and the message is getting triggered more than one times. So that's the issue. So if we just take this, right, I'm pretty sure we'll be having more than one message event. Right? So if we just refresh this as well, we'll be having more than one message event. What? Why the hell is this saying this? Show many socket connections. Uh, okay. So let's actually do one more thing. I mean, in the backend at least, in the server. While we receive the connection, let's also log the total connection. Okay. So this is there. Total is basically the uh, the IO dot the IO dot sockets dot length or the number how many total connections no IO dot sockets dot add emit. How do you get the number, like how many socket connections are there right now? uh Sockets engine dot listeners socket IO uh, get total number of connections. It's this. Oh, I think I got a clients count. There's directly something called client counts. That's also a good method. I think what you are suggesting is also something very useful. Let's actually go to the VS Code and let's do it. So io dot engine dot client count. Wait, what do you mean, man? There's nothing called client count. Let's use what uh, you're telling. Does that work? It throws an error. It says I cannot do that. Uh, I think listener count it will be that. But let's see. Listen, let's actually log in the server as well. It has a function, so it is a function. Okay, this is a function. Does that work? But event name was not provided. No, this is not how it works. So how do we actually log the total amount of uh, get max listeners, that listeners, what do you get max listeners? Then opt upgrade. You can get the connected client count from socket.io.client. Uh, okay, sockets.length. Okay, correct. The listener count is not like that. Will tell the listener count on a particular event. So you can say io.sockets.length dot size. What size is like? Yeah, yeah. We are done. We are done. We are done. I think we have this will work. I think so. Mm, server is restarting. Yes, it did restarted. No, man. This is what it does. Just keeps on counting. Why do we have 6 connections? How does this even make sense? If we close one, how much we'll have? If we close this one as well. This doesn't work properly. Like this does not work as expected. Hmm. I think uh, this seems good. This is still not working. Let's have. I'm done with this. Okay, let's have a connection count. So let's start with 0. If there's a connection, let's say con count plus plus. If this socket disconnects, we have the it constant, right? So let's call it lead. If the socket dot disconnect on disconnect, simply con count minus minus, yeah. And let's give it over here like this. I mean like this. Okay. 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 Now let's try this again. So uh, localhost 5173. Test. It should show 1. It's showing 4. Wait, hold on. I have disconnect this one. I have the problem is this will give us this the same error if we'll be having uh, any more than one instance of so this is here. Okay, now it's working fine. Okay, so let's now try to run this. This should work fine because we only have one instance running. Of course, this will not be the case later on, so we'll be thinking about that later on. So it's see. Okay, this is correct. Now the answer is being like this. The error is not coming. I think that's at least good. So the error is somewhat solved. It should be right. Yeah, now it is right. I think. But why is the correction count is 4? 1, 2, 3, and then 4, and then again 3, and then 4. Uh, okay. So it only shows the connection. Okay, on disconnect it doesn't show. So let's actually do it on the disconnect as well. Log user disconnected, and let's call it select count total. Right. See, now I'll just show you. Okay. So let's remove this instance and let's try to only have one instance. And let's see, do we, because of the strict mode. Oh, yes. Yes, true. And we are receiving 2. Let's remove the strict mode. We do not need the strict mode. That's correct. That's due to the strict mode. It renders everything twice, which is weird. Yeah, now we have exactly one instance of this thing. Right. Yeah. The error is not coming, but the state is not changing to connected for some reason. There is no error. The problem is, why is the stun server not working? Our stun server is not getting connected for some reason. We have to find the reason, and that's the core reason due to behind like this thing not working. So this is our icing server. So it should be ice candidate. I don't know what I'm sending. It's ice candidate, which is correct. And then we say event dot candidate, right? And message dot, oh, that's the wrong spelling. That's the issue. Oh, there was a typo due to which this error was happening, I think so. So yeah, let's try this again. We have a message and offer, but there's no stun server. I mean, we couldn't exchange the stun server, but where are we actually sending the stun server? We are only listening for this, right? We are not sending any stun server configuration right now. So let's do that first. Let's see what's up with the stun server thing. So in the end, we have this add event listener. You have the ice candidate, and you just send this ice candidate thing. Uh, Ice candidate. If there's an event dot candidate, you just emit this. Let's see, do we have even ice candidates? So let's figure this out. Refresh this. Refresh this. Make call. We don't have an ice thing running. So how will we actually send this? Ice candidate is not getting called. Uh, there was no remote description set. Okay, so this is called when a remote description is set, right? So here we are setting a remote description. Here we are setting a remote description, right? Let's log setting remote description with answer, right? Let's copy this and say with offer, right? Right. I mean here. Set is being called over here. Here it is directly being set called. Let's see. With answer and with the offer, it's getting set. But yeah, but the problem is, okay, I think we have to move this. Okay, we are already there, man. Message. Uh, ICE candidate is not getting called. There's again some bug. So there's some RTC bug. Our icing candidate is not working. For some reason, our ICE candidate is not. The event for the ICE candidate is not getting triggered. This ICE candidate, and we need to figure out this. Uh, why is this bug? So I think let's try to do this for a while. Why is this not working? No ICE candidate so far. Not even receiving the ICE candidate error. So I think we have some bug over here for the ICE candidate. Let's let's end this stream right now. I think we'll be fixing this bug tomorrow. Let's see. I'll also do some R&D. You could also come doing some R&D and we can fix this. Check if we are adding an event listener and adding a log on every online 50. Online 50. Check if we are even adding a event listener. Oh, that's true. Like, is it even working in this way? Uh, yeah, yeah. This we are definitely adding I mean, we are adding a listener. See, we are adding a listener. That is surely not the issue. Icing server is not getting added. The ICE candidate event is sent to RTC peer connection when an RTC ICE candidate has been identified and added to the local peer by the call set local description. Okay. We are setting a local description, I'm pretty sure. We are setting a local description, but the ICE candidate is not coming. So in the whenever we set the local description, then the ICE candidate event is called. So here we are setting the let's do it initially rather than doing it over here. Let's actually do it at the top, right? So yeah, let's try to do it on the top over here, right? So add event listener ICE candidate. Is it ICE candidate? Is this the name of the event? It is ICE candidate, which is true, and then you know ICE candidate, and that's how you go about doing that stuff. Okay. Okay, hold on. That I just okay. Uh, hmm. No, nothing so far. Set remote description this, and then set remote description RTC description message dot offer. So the both remote description is working. I think that works after adding the media streams. That might also be the case. Okay, let's actually try that. Let's add a media stream and then let's try to yeah, that's true. Let's actually try that. So yeah, let's go to guide. What? Right. Where is the sidebar? Okay, it's here. Okay. We need remote streams. So in the peer connection, you can directly add a track. Okay, that's cool. Let's try to do that. Uh, so let's add a video track again. Let's create the ref which we had. Let's actually try to transmit the data. So you can say const video ref, right, is equal to use ref. And as we are having before, we can have like HTML video element or null, and we can give the default type as null. Right. And now what we can do is we can just go over here and maybe below this connected, we can have a video element, video element with no src but a ref. That ref will be video ref, and then we'll say autoplay and controls, right? Which is cool. Okay. And the next thing what we'll do is we'll just give a button and stream our stuff. So yeah. Uh, so for now, like let's keep it very simple. Let's give it a button and it's going to start streaming, which will basically call a function called start streaming. Start streaming. And then what we can do is we can just copy this function. We can just say this on click, right? And then might we call this function, and then we can do all those get media shit. We can say navigator dot user media media devices dot get user media. You can say video true and audio true, and then you can say dot then let's go for a sync function, right? So we will be getting our stream directly over here. I think that works. Okay. So let stream be equal to this. So and there will be a await over here, right? And then what you can do is we'll have the peer connection. So if we have the peer, there's no suggestion for this. What do you mean? If we do not have a, if we do have a peer connection, right? So it's a peer connection dot add track, and let's call it stream dot tracks, get tracks dot for each track, uh, track, right? That's how we do it, right? Yeah. And then you also pass the local stream, which is the stream, right? And then we'll be also receiving a global stream maybe somewhere here, right? So we'll be receiving a global stream. Now, how would that work? So that would be basically peer connection dot track on track, and how do you do that? Wait. Hmm. So add event listener track, and then you just say src object is equal to remote stream. Hmm. Cool. So we can add simply a event listener to this. Add event listener, and the event listener could be track, and then we can just say an event is there, and then how does it work? So you just say const remote stream is equal to event dot tracks, event dot streams, right? Then you get the first stream, and then you just say video ref dot sr video ref dot current dot src ref uh, src object is equal to the remote stream, and just reset gs ignore. I think we can go a little bit better. We can say if this exists, then only do this. No, if this, then uh, yeah, yeah. Now let's actually try this. Will we get a stun server now? Let's see. Refresh this as well. Let's make a connection and then kind of like start streaming. And why is it not working now? Uh, hmm. Okay, let's see. Are we even receiving the tracks? Yep. Are we even receiving the tracks? Yep. Let's first make the connection, right? We have the connection established. We are not. We are not receiving the track. Yes, so I think that does not work. Even after adding a media stream, it's the same thing. Actually, media stream doesn't matter. Uh, yeah. Okay, I think then let's uh, let's wrap up the video. I think we'll be figuring out this bug and we'll be finding out the answer of this bug. I mean, the solution of this bug in the next one. Even I'll do some research on my side so that we can tackle this much more quickly. Thank you for watching the stream. Have a really great day ahead. And that's all. Thank you and bye bye.